I'm Terry Schindler with Polyplexus team. We're so pleased to have you join us for what I know will be a fascinating discussion with Anna and Amy. But before we get started, a quick word about Polyplexus, which is hosting this discussion. Polyplexus is a community platform that features evidence-based conversation and opportunities around R&D and innovation topics. We'd love to have you join us. Sign up is free at polyplexus.com. And while you're there, check out our Conjecture Mania competition. The deadline to enter is April 30th. It's now my great pleasure to introduce our guests. Dr. Anna Skinner and Dr. Amy Kruse met each other originally in the DARPA ecosystem. Anna is the founder and president of BlackMoon. She focuses on efforts to develop technologies and interaction methods that foster a symbiotic relationship between humans and our increasingly advanced systems. She works across industry, government, and academia. Amy is at Prime Movers Lab looking at emerging companies in neuroscience, human augmentation, and synthetic biology. When she was a program manager at DARPA, she oversaw the agency's first neuroscience programs, performance-based neuroscience programs. And we're absolutely delighted to have you both and anxious to hear what you have to say about our future. I think to start, maybe we could just talk about the difference and where we are in cognitive science and neuroscience today. Amy, do you want to take that?
Yeah, sure. I'll kick it off with thoughts around neuroscience. Your neuroscience itself is actually a very young science, right? It isn't something as old as physics, but it is something that we have discovered over time and really came from the physiological exploration of the nervous system and then how that sort of knitted itself together to become behavior. And so neuroscience in general has been very focused on measurement of the brain and measurement of the central nervous system through methods that cover invasive measures, putting electrodes in the brain and measuring electrical activity, all the way to doing things non-invasively, whether that's a functional magnetic resonance imaging or EEG. We have a lot of different ways of peering into the brain and really comes from that tradition of maybe a little bit of a bottom-up approach of understanding how the nervous system functions all the way from fruit flies, all the way up to humans. And so very much a very tangible, I'd say, kind of discipline, which has really turned out to dovetail beautifully with where cognitive science has evolved to. And so Anna, why don't you tell us where cognitive science sort of intersects with these pieces?
Yeah, absolutely. Well, and also just kind of going back to how we met and in the context in which we met, which was working on the DARPA Augmented Cognition Program 20 years ago. And
we were both 12. We were both 12.
Absolutely, 12 years old, just child geniuses.
Yeah, totally.
But I mean, so you had just finished your PhD in neuroscience.
Yeah.
I had just finished my undergrad in biomedical engineering, and we're both coming to this program, this augmented cognition program, which was really focused on exactly what you're saying, like, what are the ways that we can measure cognitive state using physiological sensors and things like that? And, we've joked about the fact that my last name's Skinner and that BF Skinner was, a behaviorist who saw the brain as just like this black box, and that all you could do was like, what goes in and what can we observe behaviorally? But that program was really maybe one of the earlier attempts to really demonstrate outside of the lab and more as we refer to as like operational neuroscience. And I think that's kind of like the key step in between, like sort of, more classical neuroscience. Then there's this kind of in between operational neuroscience. Yeah. And then there's more the cognitive psychology, cognitive science that is where I, of course, after I met you, I wanted to be a doctor. And so I went and got my master's and PhD in human factor psychology, where I got, a little bit of neuroscience, a little bit of cognitive science, a little bit of, how to design interfaces. And so, but they're all very related, right? And so, I guess I would maybe say I'm curious from your perspective, being really the, traditional neuroscientist, like what's different 20 years ago from
Right.
when, right?
Yeah. Yeah, it's funny you mentioned that, because I remember when we first started doing real-time EEG recordings in individuals in the augmented cognition program, and many people were like, why? Like, why would you want to measure one individual's brain? And it was really this, sort of breakthrough in understanding, because at the time a lot of work had been group averages, right, and kind of munging all the data together. And there was this sort of insight into the idea that your cognitive workload and your working memory capacity, and maybe your exposure to sleep deprivation would be different than mine, right? And there would be something worth measuring about that and knowing about that. And so I think one of the things that's changed really radically over those sort of last 20 years is the idea that an individual's sort of brain state, brain activity, and what you can do with it is not only valuable, but like you can actually build entire applications and projects and now products, sort of off of that, right? And so all of that for me was sort of that clear moment of like, why would you want to do an individual's brain? And now it's sort of like, why wouldn't you? Like, we track everything about ourselves, right? And so it was really
the Oura ring to measure our sleep.
Right, exactly. You got one before I did. I got one because you had it. So, but yeah, so actually, now that we talk about the Oura ring, it's interesting. Maybe we can just feather in what we just talked about into a little bit about human performance.
Yeah.
And so, maybe from your perspective, especially with the human factors, sort of background and the work that you've done in various companies. What do you see in performance? And then maybe I'll kind of bounce back and share some things that I have, over the last few years, observations on that.
So both from my experience work-wise, but also just being interested in these things and curious about these things, and also being somebody who loves data and thinks there is value in data. And, it's funny you say, like, why would you measure that? And we kind of had a mantra in AugCog of like, if you can measure it, you can manipulate it. Like, if you can measure it, you can then, play around with, under these conditions, how is it different? And how can I then find that, optimize performance? And, I mean, the Oura ring's a perfect example too of just more kind of ubiquitous, mainstream interest in measuring your own data and having a better understanding of your own physiology. And because there are these really appreciable, significant differences between individuals, and not just between individuals, but between me from one day to the next. And so having a kind of a more and more of these like windows into how our bodies perform and under what conditions they might perform better or worse, at both the individual level, and then ultimately, I think, more at maybe at the team or organizational level, which is, I think, kind of where we were starting to try to go with augmented cognition.
Right, for sure. Yeah.
Which I don't know. I feel like we keep referring to that. Should we say more about that?
We can.
Essentially, we were, the goal of the program was to use physiological sensors to assess cognitive state, things like workload and working memory and things like that. And with the idea that particularly if you had a team of people and you were monitoring cognitive state of multiple people, if, for example, I'm completely cognitively overloaded and Amy's over there bored, the system could automatically offload tasks to Amy. And then we kind of took it a step further even, and we were looking at, could you distinguish between, if you are cognitively overloaded, is it verbal or spatial? Because you've got two different types of working memory. And so maybe I'm completely overloaded, but I'm just verbally overloaded. And you can, present more information to me, but it's got to be spatially instead of verbally. And so I don't know. I think there's just still so much like fascinating in that space that we haven't fully taken advantage of.
Yeah, no, I agree. It's interesting. I'll kind of return to that, but also, the past few years have been doing really applied. So prior to joining Prime Movers Lab, I was at a startup working on applied neuroscience for human performance. So actually trying to take a lot of the work that we had done at DARPA, both with OGCOG as well as my own programs that I started at DARPA, and actually start applying that to folks who kind of wanted an edge with their brains, right? So executives and sports teams and financial traders and others. And I think the biggest challenge, one of the great things about OGCOG, and actually one of the great things about DARPA and the way DARPA programs are structured, is they have really tangible outcomes or metrics, right, that you can sort of measure and that you're encouraged to measure with relation to some task. I think as we tried to move into, and we have moved into, human performance and neuroscience-enabled human performance in the commercial sector, it is sometimes really hard to get enough data, right, to show someone or prove to someone that this improvement in this fundamental, cognitive or neuroscience element has an impact on performance, right? Yeah. So, I know exactly how to improve your visual processing speed, right? I don't have all the data on whether or not that will make you hit more home runs, right? And those are the tricky things, I think, as you move to commercial applications. Is when you move to commercial applications, you really have to have that tight coupling between, what the, let's call it what the tweak is, right, and what the outcome is, in performance or behavior. It's still very open loop right now, in that context. And even our Oura rings are open loop, right? It's up to us to modify our behavior in response to the data that we're getting back, right? I don't yet have a perfect Oura headband, right, that goes with this, that augments my sleep while I'm, while I'm resting. And so I think one of the beautiful things about OGCOG was that it had these really defined metrics and outcomes where we could show, changes in performance on very particular tasks, and we were sort of set up to do that. And I think as you transition things to commercial sector, it often becomes harder to get the proof points for some of those, which is part of the challenge of selling, I think, in those kinds of environments. So I'm curious. I know you've done a lot of work in, especially the work that you've done more recently at DARPA, in the merger between sort of humans and computers. I know people are really interested in neuroscience and cognitive science and AI. What have you seen? Like, you've been on the front lines from some of the really cool programs that are happening right now. What are some of your observations? And then maybe I'll share, some insights from some of the things that I've seen in the VC space.
Yeah, I mean, this is my favorite thing to talk about, and I think it's just changed so dramatically, like in the past, I would say 5 years. So even just, I was interviewing for a job 5 years ago, and I got the question, why would we improve human performance when we can just make the machines better? And that was very much, in some ways, the mentality. And I think there's also, there does tend to be this mentality of humans versus machines. Yeah. Starting with chess and Go and, StarCraft and all that. But I think what a lot of people aren't aware of is, there have been these other huge breakthroughs. There's an example of, freestyle chess, where in 2005, you had like any combination of chess players with any combination of, it could be a supercomputer or a laptop or whatever. And you had grandmasters with a supercomputer, and they lost to two amateur chess players with 3 laptops, because they just had figured out how to do that human machine teaming effectively, how to let the machines do what they're good at, let the humans do what they're good at. And, it doesn't mean we figured out really how to do that generally. And I think that's still where we're really trying to go. But I'm really excited that I'm seeing more and more of that. Like it certainly within DARPA, there is much more of an appreciation, I think, for the human side of the equation.
Yeah. We always hear these doomsday messages, like the robots are coming to take your lunch money, and it's, it's not so black and white, right? And
Right.
I was on a study a few years ago, the Defense Science Board study on autonomy, and as we looked at autonomy, we realized, and this is after having all these discussions with experts and really looking at everything, that it's really these hybrid systems of machines and humans that are going to be the first application space, right?
Yeah.
I mean, I'm really going to date myself, right? But like, I was part of the DARPA Grand Challenge, right? Like I was standing there with a clipboard and I stopped making sure like robots didn't run over people,
Right.
and we still don't have, everyone, the roads are not filled with autonomous vehicles yet, because that complete level of autonomy is still something we're figuring out. But those blended levels of autonomy, where the centaur is, right, where the team is stronger together, I think is sort of one of the places that's most exciting. And I would like to see, a lot more development and a lot more input from the human, not just the human behavior, right, as we were talking about before, but like actual state of the human, right? Like, I can measure your attention, I can measure your stress, I can measure all of those things. Those can absolutely feed into, a human machine sort of, fusion team or team of teams, right?
Yeah.
Which I think is really, really exciting. Do you think we'll get there? Do you think we'll get there to the point where we can actually start taking some of that physiology and putting it into the AI, like for the team?
I do. And so one of the programs I'm supporting right now at DARPA is looking at trust in AI.
Ooh, I love that.
And again, kind of coming back to this, like, humans versus machines, as opposed to humans teaming with machines. So some people might be aware, we did a sort of a competition in 2019. And it started in 2019 and it culminated in a final event where it was, we had 8 different teams developing dogfighting algorithms.
I watched it. It was so cool. Yeah.
Yeah. And then at the end of it, we had the winning AI went up against a human fighter pilot in a flight simulator, and the AI won 5-0. Now, everyone acknowledges that there were some things that were very unfair about that. It was meant to be a demonstration of just the, the art of the possible, but also, there was maybe too much of a focus on that very final event of the human versus the machine. But what it was, that whole competition actually was just a precursor to a larger program that is looking to, yes, maybe put AI on aircraft to enable the aircraft to fly a dogfight, but more importantly, looking at how the humans are trusting the AI and trying to determine if we can objectively measure using physiological measures, using even things like just behavioral, their eye tracking and what they're doing, how they're interacting with the system, to tell if they're trusting it, but ultimately so that they can be that, that team where the human can be attending to things that only a human could do, while the jet does the, really, I mean, the dogfight.
Like the perfunctory part, right?
Right.
Yeah.
But that the machine would also be monitoring and understand, A, when the human is completely overloaded, B, when the human's not paying enough attention to it, if the human's over trusting it, under trusting it. And I think, and that's something we've, I think that the self-driving car community has dealt with too, right? You have to touch the steering wheel every so often, so it knows you're not completely ignoring it. But that's not very intelligent, right?
Yeah.
And if you're on highway driving, do you really need to touch the steering wheel every 10 seconds versus have it monitor you during those, when you're in more complicated situations? So that was long-winded answer.
No, it was great. It was great. It's interesting because I often get the question about, will we ever get, generalized intelligence AI?
I think we got that exact question actually.
Oh, really? Oh, I always get that question. Well, it's interesting because we already introduced ourselves. I'm a neuroscientist, right? And animals and, whether it's a squid or whether it's a fruit fly or whether it's a human, right? We are sensory motor beings, right? We are not attached in one little spot, right? And flap around in the world. We move, we sense, right? And we cogitate because we have the brains to do it, right? And so one of the things, there's this whole there's an area around this called embedded cognition or embodied cognition, and I am very much of the mindset that I think it's worth looking at these complete systems if you're interested in really sophisticated intelligent systems. I won't call it AI, I'll call it intelligent systems, because I do think the brain evolved this package, this sensory motor package for a reason, right? And for an output, for a purpose. And part of why that system is able to learn and do what it does and everything else is because it's got these inputs and these outputs. And so I would be very excited to see, folks start working on that combination of sensory motor integration again, because to me, that's part of the magic of intelligence, right? But I don't know, what do you think? Do you think it's
100%? I think that's an even bigger leap than where I was going, because I think that piece of it is really gets extremely complicated really quickly, right? And something that just I've been thinking about a lot lately is I've been kind of playing around with different terms, but like one that I've been kind of using lately is collaborative cognition.
Ooh, I like it.
Between humans and machines, having sort of a shared cognition that facilitates collaboration, and whether that collaboration is on purely cognitive tasks, or if, as you're saying, it's more sensory motor, perceptual, anything. But part of my thinking there started with, and again, coming back to kind of teaming, looking at examples of good human teaming, right?
Exactly.
And what is it that makes us really good at teaming with one another? And part of it is even just, I can sense when you want to say something, and I can pause, and I can, infer, and I have a theory of mind of who you are. I have, if we were completing a task together, I would understand your role and my role, and I would understand, I could put myself in your shoes, basically. I also could understand the context of the activities that we're doing, and it could be different in different situations. Whereas, and I think that's where the machines just aren't there yet. There's a lot of work in that area, but I think this idea of having what we as humans call shared mental models, but having the machine equivalent of a cognitive model of a thing, but also a cognitive model of the context in which that thing is, whether it's, having to do with driving, or could be really anything. And so I don't know, it's something I'm really excited about. And I do think it's possible to have, I won't say shared mental models, but shared cognitive models with machines. And I think that the humans, again, if you've got kind of this shared world model, there are aspects of information that the machines can provide very well, but then you may need for some time in the near future, the humans to apply the context.
Yeah. While you were talking, I was thinking about, what machines are good at, what humans are good at, and seeing, again, now I'm a partner at a VC firm, right? Prime Movers Lab. We invest in breakthrough science to impact billions of lives. It's a deep tech fund. It's really like, to me, it feels like the continuation of sort of what I've been doing across my career. But we're definitely seeing a lot more kind of, I'll call it machine learning in this context, across neuroscience data, behavioral data, life sciences data. I think we're at a point where we're starting to get really interesting insights from kind of that machine read of things that may have been traditionally, always done by humans, right? And, certainly if your radiologist isn't using some type of AI or machine learning, you probably wish that they were, right? To sort of capture some of those things. And I think that's another version of the kind of teaming that we've been talking about, right? Is like, is there a way to triage through things, or sort through things, or infer things at a scale that the human brain can't comprehend, but at the same time, the human is really the decision-making element based on context, experience, all the other pieces of information that are coming in. It's so interesting to see how that has permeated permeated the life sciences now, and especially the neuroscience work, that we see. I'm curious, well, somebody typed into the chat, they were curious, do you think the AI won in the dogfight 5-0? Do you think it would have changed if there were 10 rounds or 20 rounds? What's your situation?
So we actually gave the pilot a good bit of training with the AI in advance.
Okay.
So, he had more than just those 5 rounds. I do absolutely. You could see he was developing more precise tactics. I'm sorry, he didn't train with that exact AI.
He just trained in like that environment, right?
Right, yeah. with a couple different dogfighting agents. He didn't know which one was going to be the winner, and therefore the one he was going to go up against. And so he probably had not had experience with that particular one, so it's a good point. And he certainly was starting to develop a strategy and starting to understand what its strategy was. Again, having that sort of theory of mind and understanding then how to potentially, get an edge on it. But so yes, I think it wouldn't have been quite so much of just a crushing defeat to humanity.
Yeah, sure.
Maybe given him a little, a few more tries at learning it. But again, that's part of the piece of what we're going to be looking at next, though, is for a pilot having that on your aircraft.
Yeah.
If you fly with it often enough and learn how it works, you know when to trust it and when not to. And
right.
yeah.
I love that part. I love that. I mean, I love the adaptive part. I love the word that you've chosen, the collaborative cognition, because it doesn't feel adversarial, right? Like when we come together and we form teams and we work on stuff, right? It's collaborative cognition because we're humans. We have, like we said, some shared mental models. We have maybe a shared sense of purpose, a shared motivation. Even if you put some humans together and you give them a shared motivation, right? They'll eventually kind of fall in line. And I just think it's an interesting thing to remove a little bit of that, like, head-to-head competition piece of it, and think a little bit more about how you're talking about it. Like if it's riding along, if it's your virtual wingman or whatever, right? That's a very interesting and potentially enabling technology. And you can think of, a host of ways, not just in a dogfight, right? But in a host of applications where that would be really advantageous.
Yeah, I mean, I think the other part of, that sort of collaborative cognition, or whatever you want to call it, is, in human teams, you've got people who are good at one thing and not so good at another. And, you're going to divide and conquer in an intelligent way based on your skill set. And so, and it's dynamic. And so being able to get to the point where we have that kind of dynamic collaboration with our machine teammates is, I think, where we're really trying to go. And that's part of, with the dogfight. It's not to say
right. AI is superior and there will be more pilots, right?
Right. Yeah. No, it's, if the machine's doing that, you can, do things that the machine can't do. So do we have other questions?
There's another one, which I really liked, which was, sort of what outcome or accomplishment would you consider a grand slam home run in your field in the next 3 to 5 years?
Oh, from Michael Arnone.
Yeah, home run. So what do you got?
You go first. No.
Oh. I'll go first. I always have some crazy idea that.
All right, go for it.
No, I've said this in other contexts, and so I will admit I didn't know the question was coming, but I always have this at the top of my head. I'm really interested in where neuromodulation is taking us. Neuromodulation being the idea of using non-invasive methods to augment one's brain state or brain activity, right? So we have, transcranial direct current stimulation, transcranial alternating current stimulation, transcranial magnetic stimulation, transcranial focused ultrasound, right? We have all these really cool, really different ways of modulating the brain non-invasively. For me, I envision a future where we will be able to dial in using neuromodulation the states that we would prefer to be in. So if I want to be focused, I'll be able to dial in some focus. If I want to be creative, I'll be able to dial some creative in. And if I need like a super relaxed, very restorative, awesome night's sleep, I'll be able to dial that in as well. So if we were able to, non-invasively modulate state on a regular basis at the individual's choosing, this is all under their, choice and guidance in 5 years, that would be a grand slam.
Yeah, absolutely. And I think there's so much involved in achieving that, and then so many applications. And one of the areas, again, back to the Oura Ring, that I'm just really fascinated with is sleep. And I think there's been some indication that we can actually, using transcranial direct stimulation, or stimulating the vagal nerve, or whatever, that you can actually induce deep sleep. And so again, that back to that, like, if we can measure it, we can manipulate it, really, or modulate it, as you said. And to be able to detect when there's a deficit too. Maybe it's not, I want to be in this state right now, but to have an objective measure of, I'll just use the example of sleep, but that, you are not at the top of your game right now. Is it because you haven't eaten in 5 hours, or is it because, to have a way to diagnose why, and then to enable that sort of, manipulation, modulation that's individually specific, right? And I think that gets back to what we were talking about earlier, that that's what's so hard about what you're talking about, is that for each individual, that's going to look very different. And I think, you mentioned also, kind of just, based on your data, based on other people's data. And I think that's one of the amazing things about the past several years, is that we are collecting so much data on all these things, and that there's so much that, we talk about big data, and we talk about, data mining, but I think we're starting to get a better understanding of how to apply AI and machine learning in a meaningful way, to where you're not just getting these spurious correlations, or you're able to actually establish causation, not just correlation. And I think for me, that's a huge piece of it, is particularly for the brain and the body, which are so complicated and so dynamic, to be able to actually kind of get to those causal relationships, and then to be able, to be able to do something about it would be absolutely a grand slam, as Michael said.
Yeah. So is that your grand slam, or you have another one?
Or that was on top of yours, I guess. No.
I know. Is that why? Can you do 2 grand slams? I guess you could do 2 grand slams in one. Yeah.
Well, so
I was just wondering if there was anything else that you kind of had in mind.
So the other piece of that's something I've thought about for a long time, and some of this comes down to privacy issues and regulatory issues and things like that.
Sure.
But because we have this wealth of data and this ability to collect the data, I think things like stopping pandemics and also, I really think that there's so much that we can learn at more of a population level by just, if people were sharing their data, we could say, because frankly, a lot of the research in some of these areas is just not well done. Sometimes it's sponsored by special interest groups. And so if we could just look at the data itself and say, people living in this area of the world, eating this diet, moving in this way, behaving in this way, they never get cancer. Great. Let's figure why that is. So those sorts of things that I think the potential is there. And if it's done well with rigorous science and, applying machine learning in an effective way, those are things we could literally eliminate diseases. And
yeah. That would be, that's a big, we're sort of drifting into like, commercial applications now. I'm wondering if, other than sort of some of the measurement and the wearables, if there are other things that have been productized that have caught your eye. I have a couple things that have caught my eye recently, but I was just curious if you've seen anything, you know, in addition to the wearables that you're sort of keeping your eye on.
Yeah. So one, and I won't know like product placement here or anything, and it's still in research phases, but there's a company that's developing a technology that you can put on the skin, and it just has these little micro needles that can go you don't like, it doesn't hurt at all. They're these tiny little needles, and it can get into the interstitial fluid and the intercellular fluid.
Yeah.
And it turns out anything that you can detect in the blood is also in the intercellular fluid. It's just in smaller amounts. And so if we can have these, you know, you slap on a patch and you can get that level of information of, you know, non-invasively, you know, I mean, there are immediate applications, obviously, for diabetics and for, you know, a million other things, but there's just so much information there that would be so useful, and that, you know, people are afraid to go to the doctor. They don't like tests. They don't like needles.
Right. They don't like anything, right?
Yeah, yeah.
And now everything's teledoc anyway, so it's like you're not even gonna go there, right? Yeah.
Yeah, but if there were this, you know, these more kind of non-invasive, and if it became more ubiquitous and more something that you just kind of slapped on every day, and it learned you, and it learned what your healthy state looks like, and when, you know, there's something wrong, even if it's just to, you know, give you an indication to go to the doctor and get a more, you know, a higher fidelity test for something. I think that would be extremely valuable. So anyway, again, I think that technology is coming along and getting close to being, you know, something that could be commercializable and that people could have in their homes.
Yeah. Well, especially when you think about combining it with like digital health and, you know, kind of remote, like, you know, it wasn't until this year that we could, like, you know, have a COVID test shipped to your house. Somebody could watch you swab your nose, you know,
Right.
like put it in a tube. And like things are really changing in terms of, I think, access to healthcare. And one of the things that I was thinking about in terms of commercial applications and where things are headed is I'm really interested in the evolution of augmented reality and virtual reality.
Ooh.
You know, it really started out for you and I who've been playing around with it for a while, right? Like it really started out kind of in that gaming space, right? But now we're seeing these enterprise applications, right? Like what was it? Well, of course, you know, the US government buying, you know, however many HoloLenses they agreed to buy. I don't know if you know this or not, but last year, I think it was Walmart bought 10,000 Oculus Rifts because they're moving all of their corporate training to a virtual reality platform. And now you're starting to see the virtual reality headsets themselves be instrumented, right? So the face pad, right, can be instrumented, the strap, you know, can be instrumented with EEG sensors. And so I'm really interested in the evolution of this space because I think, you know, virtual reality, initially it started out with this kind of gaming focus, and I think it's turning into this real enterprise training world, which again, touches on all the things we're talking about, right? Like collaborative cognition and people being together and, you know, maybe adding agents to that, or maybe adding synthetic, you know, whatever, and this new world of a training experience that's completely virtual, that could be instrumented in the way that we've been talking about and have, you know, sort of AI or synthetic elements in it. That's been something that's really,
and the training piece of it is something that, like, you know, when you were a program manager at DARPA, you had the, you know, an accelerated learning program, and and I think that, again, like those technologies, as you said, are getting to the point where you could very easily have a, you know, functional near infrared underneath the headset. You can have eye tracking. You can have, you know, get heart rate or any whatever other EEG, and you can detect when somebody's in a good state for learning. And then, as you said, you may or may not be able to kind of induce those optimal states for learning. And I think that's potentially huge.
Yeah, well, I mean, to me, the premise behind accelerated learning, you know, as a program and even where it could be headed as a consumer application, like it's still really solid, right? Like the brain first of all, the brain loves to learn, right? You can track sort of the learning process in the brain, right? And the brain is when it's learned something and when it's achieved mastery on something, it's super efficient, right? And so the changes in brain activity as we, sort of learn, kind of struggle with and master a task are measurable. And I think that's fascinating, whether you're thinking about, as we did in accelerated learning, right? Like shooting a rifle, turns out it's just as applicable for archery or golf putting, or, you know what I mean? Like there's some real crosstalk between, I think, some of the initial applications that we had, sort of looked at, and, and now where things are headed in the commercial space. I would love to see that impact, education and training. We got a question about the intersection of biochemistry or altering biochemistry and human performance or cognition.
Oh, Joe.
From our friend Joe. I have some crazy things to say. So maybe I'll let you go first, and then I'll jump in with sort of my more avant-garde topic that I'll bring up. You have any thoughts?
Yeah. So, I mean, honestly, I think, when you start saying things like altering biochemistry, that sounds really bad, and it sounds like unnatural, but frankly, our own biochemistry is constantly modulating itself, sometimes in ways that just aren't optimal, right? And so I absolutely think that just understanding that better, and understanding really, especially, epigenetics and what's going to flip a switch for me genetically that is going to be totally different for you,
right.
And how can I monitor and control my biochemistry when that happens, I think is a good thing, right?
Yeah. So I have two things I thought of. One is, first thing that popped into my head is the microbiome, which is of course the bugs that live in your gut, right? And there's something called the gut-brain axis, and we actually are seeing companies and work going on now, essentially showing how your microbiome actually can affect your cognition, which again is a sort of biochemistry, interaction between you and cognition. And I think that's a really ripe space for sort of exploration. Most people don't know there's as much nervous system in your gut as there is in the rest of you, right? Yeah. And it's a highly innervated system, and really just starting to understand the microbiome, how to protect our microbiomes, how to enhance them. I think that's a really, really interesting place for exploration. The other thing it made me think of was the emerging space of the use of psychedelic medicines in mental health.
I wasn't going to go there, but yeah.
I was going to go. I have to go there. I'm even going to give a plug. I have on our website, we write blogs and we do webinars and stuff like that. And I have two.
So are you microdosing LSD right now?
No, I'm not. I am perfectly clean. But just the idea, and you know what, Anna, it relates back to what we were talking about earlier about neuroscience and cognition, right? When we started out in neuroscience, it was like, put the electrode next to the neuron, like it was very small, small footprint, right? Now we're starting to understand the brain as a connectome, as this big connected system of networks and states and all of those pieces. And this relates really to how, these medicines, which, will be turned into, I think, pharmaceutical type medicines eventually, in addition to, sort of their natural forms as plant medicines, they have been shown to affect plasticity in the brain. They've been shown to affect the way that those circuits around depression and addiction and anxiety and PTSD function. Right. And it's so encouraging to me that we have like a head start, because, for most people who don't know, like neuropharmacology has been kind of sad for the last couple decades. We have a couple antidepressants that don't really work that well. Right. And now we have, reinvigoration of a look at these chemistries and these compounds and how they plug into the brain and how they alter those networks. I think it's really encouraging, because to me, the idea of something that's curative for a mental health condition is really inspiring. Obviously, there's a ton more work to do,
Yeah.
but I really do think that is something that's very, sort of inspiring in terms of, chemistry and cognition and those kinds of pieces. And it's something that, it's kind of one of those things, like as neuroscience and cognition and pharmacology and all these pieces have come together, like it's definitely like it takes a village kind of.
It does. And I'm so glad you said that, especially as I know we're starting to run out of time. But I think, even when you look at the title of what we were supposed to be talking about today, and I think we were all over the map, but even the title, right? It was like brains, behavior, and human performance. And we talked about, just this, what to most people might seem like almost subtle differences between your background and my background, which, and now we're talking about how do you incorporate experts in artificial intelligence, machine learning? How do you it does take a village, and it takes an ecosystem of, cross-disciplinary interaction. And I think that's a lot of what Polyplexus is really about. And, you can find out more about that. But so I don't know, I guess my question, and this is something, also that I've observed within DARPA, because as you know, at DARPA, we've got 6 different technical offices, and they all kind of have their swim lanes. They're not completely siloed, but they live, they purposely each, cut out a field of technology and really focus there. Yeah. And my feeling is that if we do want to get to this point of, human machine symbiosis and a lot of these other things, right? Like even, you need the folks with the biology expertise, talking to the AI experts, talking to the people who understand, human psychology. And, so how do we get there though? Like, I can't even figure out how to get DARPA to,
Well, it's funny because I think it has to be intentional.
Yeah.
And when you craft a program idea, or when you bring a community of people together, it can be a little uncomfortable, right? To have all these different viewpoints and different perspectives, and obviously folks feel very strongly about their positions, and everything else. But I do think that you have to be intentional about bringing people together, because they aren't really incentivized, whether it's in the current academic system or even, across companies or across industries. Like, people need to be brought together, and there has to be some method of incentivization. Sometimes that is a DARPA program, right? Where a real cross-disciplinary topic is put out there, and you can't do it yourself, right? Like you can't just do it with the people in your lab or your own company or whatever. You have to go outside and really start to build these strategic, and intellectual alliances. And that's where I think we've seen the most success. In really breaking through technological barriers, is when people are encouraged and incentivized to work across the boundaries. I will tell you that, when I was at DARPA as a program manager, now arguably, again, I don't want to date myself, but it was a few years ago. It was a while ago.
We're only 16 then.
Yeah, so. Right. Yeah, exactly. But we were encouraged to work across the offices. Like we teamed up with other program managers, and sometimes, I know there are a couple program managers now who work across, some of the offices, maybe between DSO and STO or MTO. Right. And so, but, we might need more of that. Like the world isn't getting more stovepipe. The world is actually getting more complex.
Yeah.
Right. And you kind of need those complex thinkers and people who can work across some of those boundaries to I think get to some of those really gnarly, kind of cross-disciplinary challenges. So but that's, it's challenging but fun. Right. Like, I think, tackling some of these problems, together in a, sort of in an ecosystem or in a challenge like that. That's one of the reasons why challenges are so fun, right? Like that's one of the reasons why the AI dogfight was so compelling and fun, right? Is because people do need something to kind of like nucleate around.
Yeah.
Right?
I mean, going back to your example of the DARPA Grand Challenge, now granted, the first one wasn't super exciting, but
yeah.
But
the desert was lovely. Like the desert was lovely, and we tried again. Yeah.
Well, it just like what came out of that in terms of what we now see with self-driving cars is just insane. And again, like I said, it starts with that.
It was nucleated there, right?
Yeah.
Okay. Yeah. So now I'm gonna ask you back, because I think you kind of like punted on the grand slam thing. If you had a grand challenge that you would like to put out, no, doesn't even have to be on topic necessarily. I mean, it'd be cool if it was, but like, give me a grand challenge.
So I would say something where, we'd pick one of the topics that you and I talked about, even, for example, and you gave teams all the exact same data. Like, so maybe I'm going to give you all this health data for this area of the world. This is, what they're eating, what's sleeping. This is whatever. You're going to have all this data. Everybody, and, more likely we'd give them like, here's what the Marine Corps is doing versus the Army versus whatever. But, but you're all going to get the same data set and go like figure it out and give them a goal, whether it is, identifying, maybe abnormalities and that affect the gut.
Or disease states.
Whatever. Yeah. Predict who in this group is going to get, certain types of cancer. Predict from this data, just average lifespan of various people and things like that. Like, I just think that it would force you. You're not just going to throw that all into a neural net, right?
Yeah, no way.
Whoever has the best neural net wins. And you're going to have a multidisciplinary team that also helps you make sense of that data and understand how you would attack it with AI and machine learning.
Yeah.
So it's so interesting. I'm inserting myself back into the conversation.
Welcome back.
A little bit.
Welcome back, Carrie.
And I just think this idea of collaborative cognition and then also this multidisciplinary approach, there's sort of two sides of the same coin, right? So if we're going to talk about collaborative cognition, there's a question in the chat that I think is interesting, which says, do you feel the technology exists for the agent to infer the shared mental model of a team of humans?
I do not think it exists yet. I think that that's exactly where I would like to see us go. And it's something I've been kind of just poking and prodding at various people that might have the ability to, get a program or something like that started in that area, because I think we've come a long way in terms of machines having cognitive models of certain things, and that my other thing that I'm super excited about that I think somebody needs to do is to really explore a little bit more how we train with our machines. And that maybe comes back a little bit to, the question about, if Banger had more opportunities against the AI or maybe with the AI, would we have seen something different in the alpha dogfight trials? And I think just like with humans, we're not going to send some special ops team out to run a mission with them not have done an incredibly intense amount of individual training and then also team training. And that's how you learn each other's, strengths and weaknesses. That's how you start to develop those shared mental models of each other, of the mission, of what we call level 3 situational awareness, where I actually know what you're going to do next. Because I just know you well enough. And I think, we need to allow our machines that same sort of benefit of training with the humans. And I think it probably is something, in simulation, you're going to go through this mission together 100 times and until you both are on the same page. I mean, hopefully not 100 times, but I think it's an area I would really love to explore.
Yeah, no, it's funny because I was sitting here thinking about it, and it's one of those things where we're really close.
Yeah.
I think it's one of those things that requires effort. And again, one of these sort of multidisciplinary sort of, it's not like Anna and I haven't thought of this before. And I tried to get somebody to pay us to do it, right. but it is the case that I think we're really close. I think it's one of those things that needs to be posed as a question, and again, people align to sort of attack that problem, but it does not seem that far off to me. It seems extremely doable.
It's extremely doable for limited use cases, right? So, and I think that comes back to one of the earlier questions, about general artificial intelligence, and are we close to that? No. Are we close to having AI teammates that you'd be able to throw them into a team of surgeons and then throw them into a team of special operators and then throw them into a baseball team? No. But if you give them a specific, a constrained use case in a constrained domain and teach them the rules, I think that's not too far-fetched.
Yeah.
So then switching that and saying, okay, to the multidisciplinary model, because I think you guys have had that whole conversation. This whole conversation has been a lot about the intersections of other disciplines with what you're doing.
Right.
What are the shared mental models that we need? We've had a lot of conversations on Polyplexus about how do we talk across disciplines? Is there an analogy that you can use to sort of help create those points of intersection?
I don't know about an analogy, but I would say, sort of analogy, but I think, part of what you're talking about in those situations is just semantics and communication, and the words that you use are different and mean different things in different disciplines, right?
Correct.
Yeah.
And that is the, kind of communication challenge is one of the primary barriers between human and machine collaboration, right? We don't think or speak or convey information in ones and zeros, right? And they don't quite understand our way of conveying information. That, obviously we've made a lot of headway in speech recognition and even, potentially being able to infer when you're surprised or scared or whatever. But that, I think that that establishing those, at least understanding, like, let's have this, like, can we have some code words? Can we have some let's create our own language where we can agree on what we mean when we say this or when we do this.
Well, and Anna, that reminds me, and that in that accelerated learning program, one of the things we worked on at sort of the end of the program, just before I left, was expert teams. So we had these expert teams of folks who were navigating submarines, very complex submarine navigation tasks. We had expert teams, we had novice teams, and not only just in the outcome, right, but in terms of their physiology, their behavior, their brain signatures, right? Expert teams were literally, I always tell people, like, when we're like, hey, we're on the same wavelength, literally expert teams are on the same wavelength. But one of the things that is a hallmark of expert teams is a very efficient style of communication, right? Because the words that we use and the things that we say have real depth of information and content to them because we have those. So I do think it is absolutely the case that communication, is part of the key of unlocking this, collaborative, cognition and in shared understanding across disciplines. It's very powerful. And so, yeah.
As you said, it's because, I mean, once you have those shared words, you also have that shared context, right? And it's easier for humans, if you give me an analogy that is very, human, I can understand it, and I've had that same experience. Okay, I get it now. Trying to establish that context for machines is so much more difficult. Even if we agree on the word, and I can tell you what it is, and I can give you,
52 examples, like whatever.
Experienced it. Yeah, I don't know. So it's interesting.
Yeah.
Well, I think it's fitting that you ended on expert teams because you guys are clearly on the same wavelength on so many levels.
We are an expert team. Yeah, exactly.
And I can't thank you enough for joining us and sharing some of these thoughts. And this the whole idea of collaborative cognition and these shared mental models, I think, is really evocative and interesting. And maybe the biggest thing is, I guess, the pros don't have to be worried yet. There's not going to be augmented basketball players or baseball players anytime soon.
So far, no.
Okay.
I didn't get any takers, but
okay.
we'll keep trying. So
well, thank you so much for sharing your time and your thoughts and your research. We really appreciate it.
Well, thanks for inviting us. It was such a treasure. It's always a treasure to spend time with Anna. We obviously have a long history together, but it's always great to sort of share our thoughts with the larger audience and the larger Polyplexus audience. So thanks for including us.
Yeah, absolutely. I'm sorry we didn't get to all the questions, and maybe there's an opportunity for us to respond to those offline, but appreciate the people that actually, tuned in and, listen to us just jabber.
And this will be, we'll be putting this on all podcast channels also after this is concluded. So you can find this here and you can share it with people or look at it. And if people want to get in touch with you, I think you both have ways to get in touch with you on your website.
Yeah, easy. I'm super easy to find on LinkedIn or also through the Prime Movers Lab website. I'm very easy to find. So.
Yep. Likewise, Anna Skinner, BlackMoon. You can probably find me pretty easily on LinkedIn or just Google.
Yeah.
All right. Thanks so much for your time, guys.
Thanks again. Thanks, Terry.
All right.
See you later.